All right, we're going to do a quick lesson about nonlinear and also non-functions. We'll see a few examples, and then if you have time, head on to the slideshow to give it a practice. So just a quick definition. We have been learning about linear equations. I sure do hope you remembered that on the test. Linear equations are, or linear functions, are functions that when graphed create a straight line because they have a constant rate of change. So non-linear equations are graphs that do not have a constant rate of change. Functions that do not have a constant rate of change. Now, that of course can look like the, it could look like a broken system. So for example, we could have someone making money over time, and maybe they start, with $50. They start making $20 a month, but then maybe they get a raise and now suddenly they're making $25 a month. So this would form a nonlinear equation because the relationship is growing at a constant rate of 20, but then it suddenly changes to a constant rate of 25. So the overall function would not be linear. Not linear can also look like functions such as exponential. So exponential is something you will really get into in 9th grade and beyond. And that's for looking at things that grow super fast over time. So for example, the function would look like y equals x squared because it's exponentially growing, which means that at 1, it's at 1 because 1 squared is 1. But then at 2, it now is going all the way up to 4. And then at 3, it's going all the way up to 9. So if we were to look at these rates of change, right? The first one is going up 1 over 1. But then the second one is going up 3 over 1. And then the next one is going up 5 over 1. And so this is not growing at a constant rate of change. This is growing faster as time goes on. So this is a non-linear equation. We can also have examples such as walking somewhere, right? We could have a story problem that relates to it. So I'm walking somewhere and I'm walking at a constant rate of change. And then I see my friend on the street. And so I stop walking and I pause. And then I realized I dropped my keys back behind me. So I have to go back towards my house and get my keys. And then I continue walking on to my final destination. So we might have story problems that do not follow an exact linear pattern as well. And then you might see, or you might experience any other sort of function that has a another exponent, or maybe even a square root. We could have the opposite of the square root. So anything that does not have the form y equals mx plus b, right? Or just y equals mx. And if you venture onto the slideshow, you'll see a few more examples beyond just the ones here. But mostly what you're checking for to decide if something is linear or not is whether it has a constant rate of change and if it's going in a straight line. Okay. Now we might also experience something that is not a function at all. So we have a test in math to decide if something is, and I'm calling it a non-function. That's not really the official term, but we might just call it not a function. And when something is not a function, it is because it has more than one input for every output. So I'm going to show you what that looks like. So in all of our functions we've had so far, We have had an input, and then we put that number into an equation. So such as y equals mx plus b. And then when we get out one single answer, which would be our y, and that's what we're graphing on our equation. In these examples I showed you, especially with our y equals x squared, it is possible that I can put in the same number. No, I'm sorry, that I can put in two different numbers, but get out the same number. So let me show you what that looks like. And this is going to help you to understand what a non-function would be. So let's take the function y equals x squared. And we're going to do two different inputs, but you're going to see that we're going to get the same output. So for example, I could put in -2. -2 squared is -2 times -2, which would give me out +4. I could also put in +2 to this function, and I would do 2 times 2 is +4, so I get out +4. This is still a function, okay? I can put in one value and get out one value, or I could put in two different values but still get the same value. What I can't do is put in one value and get out two different values. That is what makes it a non-function. So I cannot put in +2 and get out -4 and +4. There's no math thing that would allow that to happen. And if it does allow that to happen, then it is not a function. The other way we test to decide if something is a function or not is on a graph, and it is called the vertical line test. In a graph, to make what I've explained true, so for this to be true and this for to not be true, you cannot have 2 points on the same vertical line. So I'm going to show you what I mean by that so that you can connect to what I'm saying. So if I were to draw a function, let's do the non-example first, right? So if I were to draw a function, let's draw it like this, right? So here's my point 2. And when I put in 2, I got out +4, and I also got out -4. This graph does not pass the vertical line test. If I draw a vertical line through my graph, the graph touches that vertical line more than once. So we know this is not a function. It does not meet the vertical line test. Let me show you an example of something that you think, oh, maybe this isn't a function, but it actually is. So let's go back and look at this x squared example. On the previous slide, I showed the one side of an exponential equation. So let's show the other side. So when a graph grows exponentially, so when I do y equals x squared, all the numbers times x squared just get bigger and bigger really fast. And then any negative number squared is the positive version. So we would also look like this. No matter what negative number I put in, if I square it, it becomes positive. So at first we might think, oh, this must not be a function, but we want to use the vertical line test, right? We might think this must not be a function because when I put in 2, I get out 4. And when I put in -2, I also get out 4. But if I draw a vertical line anywhere on this function, The function only touches my vertical line once. Therefore, this is a function. So it kind of helps us to see it graphically. And then it also kind of helps us to see what it means for the inputs and outputs. So let me make a note down here again that this is our not a function version when we're looking at the inputs and outputs. And then this is our not a function version using the vertical line test. So hopefully you learned something new through this video. We've seen linear, nonlinear, and then now we've seen non-functions. If you have the time, go give this practice on the slideshow. If not, save this in your memory and you'll come back to it next year at some point. Thanks so much for watching.